Today we can discuss the chapter 10 and also inorganic chemistry. So you will get a number of direct questions from it. Yes, blog. The first part is about the alkali metals, the general properties of alkali metals, anomalous behavior of lithium, diagonal relationship between lithium and magnesium, chemical properties, then compounds such as sodium carbonate, sodium bicarbonate, sodium hydroxide. Then biological importance of sodium and potassium. Then in alkaline earth metals, their general properties, chemical properties, and important compounds such as calcium carbonate, calcium hydroxide, calcium oxide, calcium sulfate, half H2, plaster of Paris, cement, biological importance of calcium and magnesium. So these are the important topics in the chapter. Now we can see the questions one by one. First question, the alkali metal which has the highest reducing power is, answer is lithium. In aqueous solution, the highest reducing alkali metal is lithium because of high hydration enthalpy. Most hydrating is lithium. But you know the most electropositive element is francium. Francium is radioactive, so the next one is cesium. Cesium also reducing in nature, but in aqueous solution, lithium is most reducing. Second question. Lithium shows some properties which are different from other alkali metals. Give reasons. We have studied 4 reasons, which are the small size, high electronegativity, high ionization enthalpy, absence of d orbitals. These are 4 reasons. Match the following. Baking soda. Now it is NaHCO3. Baking soda is NaHCO3. It has antiseptic for skin infection. Caustic soda. Purification of bauxite. Bauxite is mixed with NaOH. Plaster of Paris. Dentistry. Plaster of Paris is using. Limestone is using in toothpaste. Okay, here you can see. You can see it. Okay. Question number 3. Predict the product obtained by the reaction of lithium with O2. Valency of lithium is 1, oxygen is 2. Interchange the valencies. Li2O, lithium oxide. Fourth question. Give reasons for the anomalous behavior of lithium. Repetition of question. We mentioned it. Write any 4 points of similarities between lithium and magnesium. We know lithium, we can tell its chemical properties itself. Lithium and magnesium react with the nitrogen in the atmosphere to form lithium nitride and magnesium nitride. Lithium carbonate decomposes on heating, magnesium carbonate decomposes on heating. Lithium nitrate decomposes on heating, magnesium nitrate decomposes on heating. But alkali metal nitrates and carbonates are not decomposed by heating. So lithium and magnesium, they do not form higher superoxides or peroxides. Bicarbonates are stable only in solution, but alkali metal bicarbonates are stable. So these are some of the similarities. You can select any 4. Question number 5. Name the commercial process used to prepare sodium carbonate and write the chemical equations of the steps involved. Process is Solvay process. You have to remember the name of the process, that is Solvay process. For the preparation of sodium carbonate, the process is Solvay process. What are the steps involved? First, sodium chloride solution is ammoniated. Ammoniated sodium chloride solution is carbonated. Carbon dioxide is passing. Then you will get sodium carbonate, and sodium that will be converted to sodium ammonium carbonate, that will be converted to ammonium bicarbonate. From ammonium bicarbonate, sodium bicarbonate is produced. Sodium bicarbonate is crystallized and separated, and by filtration you will get sodium bicarbonate that on heating decomposes to give sodium carbonate. These are the steps. If you can remember the steps, you can write the equations very clearly. NH3 plus H2O plus CO2 gives NH4 twice CO3. Ammonium carbonate is first formed. This ammonium carbonate will react with H2 and CO2 to form NH4HCO3, ammonium bicarbonate. Ammonium bicarbonate react with NaCl to form ammonium chloride and sodium bicarbonate. Sodium bicarbonate is filtered and separated, and it on heating gives sodium carbonate. So you remember the steps, then you can write the equations. Okay. Account for the following. Blue colored solutions are obtained when alkali metals are dissolved in liquid ammonia. And this blue color is due to solvated electrons. You can see the equation also here. When alkali metals dissolves in ammonia, alkali metal form Na plus or Li plus ions, and they release the electron that will dissolve in ammonia to form a complex E minus NH3 Y times. That solution is blue in color, and therefore aqueous solution of alkali metals are conducting in nature also. Lithium and magnesium show similar properties, diagonal relation. We know their sizes are almost same, their ionization enthalpies are almost same, charge to radius ratio is same. These are the reason for the diagonal relation between lithium and magnesium. Aqueous solution of Na2CO3 is alkaline. You know, sodium hydroxide and H2CO3 gives sodium carbonate. So when it is hydrolyzed or when it is dissolved in water, you get NaOH, Na plus and OH minus and H2CO3. NaOH is stronger than H2CO3, therefore the solution is basic in nature. BeSO4 and MgSO4 are readily soluble in water because they ionize readily. The answer for due to the formation of ammoniated electrons. Here, due to the similar size, same electronegativity, charge to radius ratio, all this can be written. OH minus will be produced. HCO3 minus and OH minus. This is due to a greater hydration enthalpy of B2 plus and Mg2 plus. B2 plus and Mg2 plus readily forms due to their high ionization, hydration enthalpy. Lithium and magnesium show diagonal relationship. Give any two similarities between lithium and magnesium. Repetition of question. So you study it very well. What happens when sodium is treated with one water? Sodium dissolves in water and produce sodium hydroxide and hydrogen, liberates hydrogen. In NH3, blue colored solution due to dissolution of sodium in ammonia, along with the Na plus ions, what forms? Electron. Ammoniated electrons also will form. So questions are repeating. Na NH3X times plus E NH3Y times negative. You can see this equation is important. You study this equation. Next question. The S block elements of periodic table consists of alkali metals and alkaline earth metals. A. The hydroxides and carbonates of sodium and potassium are more soluble than that of corresponding salts of magnesium and calcium. Explain. Here, hydroxides and carbonates of sodium, They are more ionic, that is the reason. Sorry, here the answer given is not correct. Okay. Alkali metal hydroxides and carbonates are more soluble. The reason, they are readily ionized, more ionic than salts of calcium and magnesium. They are alkaline earth metals. Alkali metal hydroxides and carbonates are more ionic than the hydroxides and sulfates of calcium and magnesium. Therefore, they are more soluble. Write the chemical name of the following: caustic soda, sodium hydroxide; baking soda, sodium bicarbonate; slaked lime, CaOH twice; milk of lime, solution of calcium hydroxide. I'll repeat: caustic soda, sodium hydroxide; baking soda, sodium bicarbonate; slaked lime, calcium hydroxide; milk of lime, solution of calcium hydroxide in water. Okay, question number 9. Match the following. Apart caustic soda, if you compare caustic soda, what is caustic soda? Sodium hydroxide, that is prepared by electrolysis in Kastner-Kellner cell. So caustic soda and Kastner-Kellner cell. Sodium carbonate is prepared by Solvay process. Magnesium hydroxide is an antacid. Sodium bicarbonate, mild antiseptic. This one also a repetition. Cement is an important building material. Explain the manufacture of cement. So here you can see the matches. Cement is prepared by heating clay and limestone. On strong heating, they fuse together to form cement clinker. This clinker is mixed with the 2 to 3% by weight of gypsum. The cement can be manufacture of cement. Alkali metals dissolve in liquid ammonia to give colored solution. Why? Due to solvated electrons or ammoniated electrons. It is asking for the third time. So you will understand, I think you may understand the importance of this question. Alkali metals in liquid ammonia. What happens? That dissolves in liquid ammonia to form ammoniated alkali metal ions and ammoniated electrons. Ammoniated electrons give blue color, and that will conducting in nature due to this ammoniated electrons. B. Plaster of Paris is an important compound of calcium. Give the chemical formula of plaster of Paris. CaSO4 half H2O. Identify the property of plaster of Paris which helps in plastering of broken bones. Plaster of Paris that will, when it is mixed with water, that will set immediately. When it is setting, slightly swells. Okay. Alkali metals are highly reactive due to their low ionization enthalpies. The alkali metals which act as the strongest reducing agent in aqueous solution. Repetition of question, it is aqueous solution, it is lithium. How sodium carbonate is prepared using Solvay process. Repetition of question. Is this method suitable for potassium carbonate? Justify. Sodium carbonate is by Solvay process. You may remember the methods. Ammonia is passed through sodium chloride solution, brine solution, and carbon dioxide is passed. Ammonia will react with the carbon dioxide to form ammonium bicarbonate first. Ammonium carbonate first, then changes to ammonium bicarbonate. Ammonium bicarbonate reacts with the sodium chloride to form sodium bicarbonate. That is precipitated and separated by filtration. Then on strong heating, sodium carbonate will be produced. But if you use the same method for the production of potassium carbonate, there is a problem. Potassium bicarbonate is the product, isn't it? Potassium bicarbonate is more soluble than sodium carbonate, therefore it is very difficult to precipitate it. So precipitation and separation is difficult, so it is not a suitable method for the preparation of potassium carbonate. That is explained here. Potassium bicarbonate formed is highly soluble in water, so it does not get precipitated by the addition of ammonium bicarbonate. We cannot precipitate it. That is the problem. The various steps are given here again. You study it. Question number 12. The metal present in the chlorophyll of plant is, all of you know, it is magnesium. Give two uses of caustic soda. Already we mentioned the caustic soda for purification of bauxite. That is using. In the chapter hydrogen we discussed demineralization, regeneration of cation exchanger. Degeneration of anion exchanger by sodium hydroxide, caustic soda. You can write it as a laboratory reagent. When sodium metal dissolves in liquid ammonia, it gives deep blue color. It is repeating again and again. Chlorophyll, magnesium. Caustic soda can be used for the manufacture of soap, petroleum refining, in the purification of bauxite, in textile industry, laboratory reagent. There are a lot of uses, you write in it too. Again, match the following. Before that, the reactivity of alkali metals is different for different metals. How do alkali metals react with the air? Towards air is different for different. Alkali metals react with air. You know, lithium react with the air to form lithium oxide and lithium nitrate, Li2O and Li3N, 2 will form nitride. Sodium reacts with the air to form Na2O and Na2O2. Other alkali metals react with the air to form their peroxides and superoxides. For example, potassium forms KO2. KO2 is superoxide. Now match the following. Try to find out the matches. Sodium hydroxide, caustic soda, anhydrous calcium sulfate, dead burn plaster, calcium hydroxide, slaked lime, sodium bicarbonate, baking soda. We repeated it several times. Here you can see lithium. When you write it is reaction with air. So lithium only can react with the nitrogen in air to form lithium nitride. That also you can write here. Okay. Match the following. Again, it is there. Give reasons. KO2 is paramagnetic. If you have such a question, simply you write due to the presence of unpaired electrons. But you can write due to the presence of unpaired electron, KO2 is paramagnetic. 2. Solutions of alkali metals in liquid ammonia are blue in color. Solvated or ammoniated electron. What is the reason? Ammoniated electron. Match the following. Quicklime. What is quicklime? Calcium oxide. Where is it? Here, calcium oxide. Plaster of Paris, CaSO4, half H2O. Bleaching powder, CaOCl twice. Slacker lime, CaOH twice. Can see it. Question number 15. Fill in the blanks. The suspension of magnesium compounds in water used is an antacid. The compound is magnesium hydroxide. 2. A mixture of calcium oxide, quicklime, and caustic soda, NaOH, is called soda lime. Soda lime is using in organic chemistry for the production of carboxylic acids, decarboxylation of carboxylic acids. 2. A mixture of calcium oxide, quicklime, and caustic soda, that is soda lime. B. When CO2 is passed through lime water, it turns milky. Lime water is calcium hydroxide. When carbon dioxide is passed through calcium hydroxide, that will form calcium carbonate. So it turns to milky. On passing excess carbon dioxide, when you pass excess carbon dioxide, calcium carbonate again changes to calcium bicarbonate. It dissipates. When it is forming calcium bicarbonate, that will dissolve. Give the chemical reactions involved in the process. These are the reactions. CaOH2 plus CO2 gives CaCO3 plus H2O. First CaCO3 form. CaCO3 plus H2O plus CO2 gives CaHCO3 twice. Again, calcium bicarbonate is formed. Alkali metals and alkaline earth metals belong to the S block of the periodic table. Name the process used for the industrial preparation of sodium carbonate. What is it? Solvay process. The above method is not suitable for preparation of potassium carbonate. Here's the reason. In Solvay process, the first step is production of sodium bicarbonate, which is comparatively less soluble in water, so can be precipitated and separated. If we use the same method for the production of potassium carbonate, first we have to produce potassium bicarbonate. That is highly soluble in water, therefore precipitation and separation, that is very, very difficult. So we cannot use it. Repetition of question. Draw the chain structure of beryllium chloride in solid state. This is a chain structure of beryllium chloride in solid state. Write the chemical equation showing the preparation of plaster of Paris from gypsum. Heat plaster of gypsum CaSO for 2H2 at 393 Kelvin. Then you will get a plaster of Paris. CaSO for half H2. If you heat it above 393, then dead band plaster. What is it? Anhydrous calcium sulfate will form. Lithium and magnesium belongs to first and second groups in the periodic table. They resemble each other in many properties. Name such a relationship. What is it? Diagonal relationship. Give one similarity between lithium and magnesium. Already we discussed. Both react with nitrogen to form nitrides. A compound of calcium is used in hospitals for setting fracture of bones. Plaster of Paris. Write the name and formula of the above compound. Plaster of Paris, formula CaSO for half H2O. What is dead band plaster? Anhydrous calcium sulfate. That is dead band plaster. Beryllium shows diagonal relationship with the aluminium. Mention any two similarities between beryllium and aluminium. Beryllium chloride, that is joined. Similarly, aluminum chloride are also joined. That means aluminum chloride is a dimer, but beryllium chloride is a polymer. The bridged structure. They have bridged structure. Lithium and beryllium and aluminum are not really attacked by acids due to the formation of oxide film. Then match the following. Sodium carbonate, Solvay process is simply repetition. Beryllium chloride, chain-like structure in solid state. Sodium hydroxide, Castner-Kellner cell. Sodium hydroxide is prepared in Castner-Kellner cell. Sodium hydrogen carbonate, mild antiseptic, sodium bicarbonate. 19, 3-step. There are 3 columns. You have to match the 3 columns. Gypsum. What is gypsum? Calcium sulfate. That is present in cement. Milk of magnesia. Milk of magnesia. The main component is magnesium hydroxide, and that is using as an antacid, washing soda, sodium carbonate, produced by Solvay process. Alkali metal sodium, which has a violet flame. Okay. Monovalent Na plus K plus ions and divalent Mg2 plus and Cl2 plus ions are found in large proportion in biological fluid. In which part of our body sodium and potassium ions are permanently located? That is permanently located in cell fluid. B. What are the major roles of these Na plus and K plus ions in our body? Biological importance, that is very important. You can expect this question. Both Na plus and K plus ion participate in the transmission of nerve signals. K plus ion activate many enzymes. For making which part of our body is calcium mainly used? Bones and teeth. Everything is very simple and known to you. Give the name of the metal present in chlorophyll. Magnesium. Repetition of the question. 21. State whether the following sentence true or false. Metals in the second group are called alkali metals. No, it is false. Alkaline earth metals. Alkali metals are not found in free state in nature. Absolutely correct. Because they are highly reactive. Baking soda is chemically sodium hydrogen carbonate. That is correct, sodium bicarbonate, baking soda. Portland cement is basically silicates and aluminates of calcium. That also true. Fill in the blanks. Molecular formula of plaster of Paris, repetition, CSO4 half H2O. Then beryllium shows diagonal relationship with the aluminium. Beryllium, lithium and magnesium, beryllium and aluminium. The metal present in chlorophyll, magnesium, all of you know it. Solvay process is associated with the preparation of sodium carbonate. Okay. The group 1 metals of the periodic table of elements are collectively called alkali metals. Write the general electronic configuration of alkali metal. What is it? NS1. Very simple question. NS1. Identify the alkali metal exhibiting anomalous properties. Explain. Lithium, due to 4 reasons. Already we small size, ionization enthalpy, high electronegativity, absence of d orbitals. Alkali metals are normally kept in kerosene. Why? Because they are highly reactive. They will react with atmospheric air. They will react with the water also. So we can keep them only in kerosene. Alkali metals are never found free in nature. Give reason. Because of their high reactivity. Okay, everything is a very simple question. 23. How will you prepare CaOH twice and CaCO3 from quicklime? CaO On slaking, that is treating with the water, that will change it to CaOH twice. CaOH, when you pass carbon dioxide through CaOH twice, it will change to CaCO3. CaCO3 on strong heating gives CaO plus CO2. CaCO3 plus H2SO4 gives CaSO4 plus H2O plus CO2. These reactions are very important. You have to study it. Okay, CaO plus CO2 gives CaCO3, CaO plus H2O, CaOH twice plus CO2 gives CaCO3. You can write this one or one more step here. When CO2 passed through lime water, it turns milky. Repetition of the question. What is the reaction in the above case? CaOH twice plus CO2 gives CaCO3 plus H2O plus CO2. What happens when more CO2 is passed to the milky solution? Why? That will become clear solution due to the formation of calcium bicarbonates. Repetition of the question. 25. Lithium of the first group resembling magnesium of second group in the periodic table. What is the name of this relationship? Diagonal relationship. What is the reason for it? I'm telling it 5 or 6 times, isn't it? Diagonal relationship is due to similar size, similar ionization enthalpy, similar charge to radius ratio. Small size, high electronegativity, and polarizing power, charge to radius ratio. List any 2 similarities between lithium and magnesium. Already we discussed it. Okay, we discussed many questions here. You studied very well. Then you can answer any question from this chapter. Okay.